Hi, everybody. Today I'll offer a brief walkthrough of my Web GIS Final Project methodology and outcomes. The purpose of the project is to explore electrical power production in the United States and provide insight into ways to transition from fossil fuels to clean renewable energy sources, such as wind, hydro, solar, biomass, and geothermal. These are not necessarily perfect solutions either, but it's important to move away from fossil fuels since they're non-renewable and harmful to the environment and also just unhealthy for nearby communities. So to address the problem, I began by studying 3 web services I found in Living Atlas. The first service I found useful was this one, a web map featuring a point layer that shows the locations of power plants in the United States, symbolized based on whether they utilize clean or renewable energy sources or not. The green points represent clean and or renewable energy sources, and the orange points represent non-renewable sources. This layer was created by the federal user community, and it references data from the U.S. Environmental Protection Agency. The nuclear is symbolized with purple points because it kind of deserves its own category. It's technically not renewable, but there's plenty of nuclear fuel in the world for electrical power production. I also wouldn't consider it a clean option. It's really innovative and it doesn't produce carbon emissions, but it's a risky proposition just due to radiological hazard of spent fuel, not to mention the risks involved with in the event of a nuclear power plant failure. Several of which have occurred in the past and some in not so distant past. This layer also includes a custom symbol size expression, which I thought was interesting. I did not make it, but I found it interesting and worth mentioning. It varies the size of individual points based on plant annual net generation in megawatts, and also the view scale that the user selects. So that is what is determining the size of the points you see displayed in the layer here. And a cursory glance at the layer itself gives you a pretty good idea of where you expect highest carbon emissions, although it doesn't take into account things like motor vehicle traffic also. So there are other sources of carbon emissions as well. The next layer that I found interesting is a tiled imagery layer released by Esri. It features data from the National Renewable Energy Laboratory. It shows raster imagery of average wind speeds across the United States, with the darker blue areas being higher average wind speeds. This also creates what's called a dimension animation. It allows the user to view average wind speeds at different elevations, which I found to be really neat and really useful, maybe to this analysis. And I found this to pair nicely with the next publicly available layer I obtained from Living Atlas, which shows a geographic representation of the US wind turbine database. This is a feature layer also by Esri. It includes point data for wind turbine locations across the United States. And adding this to the average wind speed layer allows for a very simple assessment of potential opportunities for the construction of new wind turbines. There are other factors to consider, of course, but this is good for a cursory assessment of opportunity areas for building wind turbines in the future. After this initial exploratory phase, I searched for data sets outside of ArcGIS Online, and I came across a great Excel data set from the Environmental Protection Agency called Emissions by Unit and Fuel Type. The applicable data sheet shows very useful data on methane and nitrous oxide emissions. That is the sphere on the right side is those columns. I saved a version of this Excel document and opened it in ArcGIS Pro. And it is this tab here. This is the original data that I used. It doesn't have geocoordinates, but it does have city and state fields. And that allowed me to geocode the data to produce a point layer. I chose to symbolize the resulting layer based on methane emissions in metric tons of carbon dioxide equivalent. And this data set originally contained over 250,000 records. I regret I didn't realize that until after I used the geocoding feature. I thinned out the data set after the fact by performing a select operation on my geocoded layer to limit the data to plants that had a significant amount of methane emission in the given time period. So this allowed me to reduce the data set to just over 87,000 points, which of course is still quite a lot. I then performed some analytical techniques. Let's see. On the reduced data set, looking for a good way to emphasize areas of high carbon emission. I started with the kernel density analysis, which is good for visualization, but I wanted a point layer to add to my web application. So I also ran a hotspot analysis of the data, and it's highlighted many hotspots across the United States. And I decided to use it as the basis for a web feature layer. And that is here. The previously mentioned layers are the basis for a web application I created in ArcGIS Web App Builder to facilitate the user's analysis and understanding of the different methods of energy production in the United States. The application is also meant to help users in the visualization of elements of the necessary transition to clean and renewable energy. And that is this here. The app has a search feature that utilizes ArcGIS World Geocoding Service would be the one to use. And it also has a query widget that allows the user to query the US wind turbine database layer. It runs pretty slowly since I have so many data points, unfortunately. But it does provide several options. You can show spatial relationships to other data sets here in the app based on a variety of criteria. There's also a nice a swipe feature where you can overlay hotspot data, or you can start with the hotspot data and then overlay the wind turbine data. So there's that option. There's a select feature. You can select and zoom to. Also takes some time. The user can add their own layers from a variety of sources, or even a file upload, their organization, ArcGIS Online, or their own content. They can change the base map. They can view the legend. They can view a layer list. And this project is meant to provide insight into the feasibility and benefits of expanding the nation's clean and renewable energy production assets. The emphasis is on wind power, but other renewable sources may be better suited to some of the areas shown that have the highest energy production carbon footprints. And thank you for your interest in the subject and for taking the time to view this presentation.